Students, we're on chapter 1.5, and I'd like you to follow along with me. Be sure and write down everything as notes so you can study it for your exams. But we're going to jump into things right away here. Um, so chapter 1.5 has to do with probability, and probability means how in the word itself, the word probably, something probably is going to happen, okay? So anyway, that's the general topic, but I want to review a little bit of finding the percent of something. If you're trying to find the percent of a number, um, let's say you had, uh, let's say this one right down here, 20 out of 60 people did something, okay? They won a prize, 20 out of 60, and they wanted to know that what's the probability or the percent. We'd express it as a percent. So what you're going to do is punch in your calculator 20, the top number, okay? If I write it more easily like this, if I divide 20 by 60, so 20 divided by 60, I'm going to get a decimal here. It'll be 0.33. And to change a decimal to a percent, you might remember from a previous class, you move the decimal point 2 places, okay? So it's 33%, okay? So, for instance, if I had 25, another example is if I had 25 out of 100 people and they ask you, what is the probability that 25 out of these 25 out of 100 people, let's say they won a prize, okay? What is the probability or the percent that are winning the prize? I would take my calculator and take 25, divide it by 100. I would get the decimal point 25 right here. And then I would change that to a percent by moving the decimal 2 places, and I'd have 25%. So 25% of the people looks like are going to win a prize, okay? So it's a very quick review of finding a percent of something, 2 out of 10 people did something, okay? What is the percent? Again, divide 10 into 2, you'd get 0.2, you would move it and you get 20%, okay? So that's just that little review. Now, with that in mind, I want you to make sure you write down this concept here of relative frequency, okay? Relative frequency is usually they're talking about the number of times that an event occurred. You'll notice, since I'm an English teacher, past tense here, relative frequency. So, and that's kind of key, that'll be key for your next concept, okay? So, relative frequency is how many times something occurred. So, in my example here, if 15 women out of 75 were diagnosed, again, past tense, it occurred, with cancer, what is the relative frequency, okay? To find the relative frequency, you might want to write this down. You divide the number of times something occurred, okay? In this case, we found out that 15 people, it occurred that had cancer, by the total, okay? So if I wrote it as a formula here on the screen, it'd be the number divided by the total. And that is how you figure out relative frequency. And it also happens to be how we figure out experimental probability, which is coming, all right? So in this case, if 15 out of 75, if I divide 15 by 75, I'm going to get 0.2 over here on the screen. And I'm going to turn that into a percent by moving it 2 places, and it's 20%. Now, next concept, experimental probability. And I'm just going to pick another color here for a second just to make it easier to see what I'm doing. But experimental probability is the chance that something will happen. You'll notice that I capitalize this. Now we're talking about likelihood of something happening in the future, okay? And polling, presidential polling, to see how many Americans approve of the president or might vote for somebody else. They use polling, they use this kind of experimental probability all the time to collect data, okay? So for example, if they did a survey and 40 people, they called 100 people a total. Here's my total, okay? So that'll help me just remembering my formula here. And here's my part. This is what we found out. 40 people said that they like the job the president is doing. We say that 40% of the nation approve of him in general. They would kind of extrapolate or guess from that data that the experimental probability, okay, of people voting or approving of the job the president is doing is about 40%. okay? Now, you're not literally calling all 400 million people in America to ask who you're voting for. You're taking a sample, and then you're kind of guessing a probability that that's the percentage of the whole country. So again, to find out experimental probability, you use the exact same formula, okay, of relative frequency. It would take this, divide 40 by 100, and I'd get 0.4, maybe 0.40 if I wanted to write like that, and I'd move it two places, and that becomes 40, and that would be my percent. That's how we express it. All right, I'm going to jump to my next screen here. You're going to get a lot of this kind of thing in your homework. Also, you're going to see this on your first exam. They might give you this much information, and then the question at the bottom of the screen, well, first of all, let me explain the chart. They're asking people, do you drink at least 1 cup of coffee a day? Okay, 1 cup of coffee per day. And they've got various age groups here. They ask people 18 to 44. They ask a total of 744 of them over here, and 357 of those age group said yes. They asked people 45 through 64. 342 said yes out of 519 that they asked. So, and then the people in the 65 and above group, 196 people said yes, they drink a cup a day, but they only asked 266 65-year-old plus people, okay? And so they might ask you, okay, what is the experimental probability of someone from each age group drinking 1 cup per day? Well, how would you figure that out? Well, I can say, well, if 357 of the, I'm going to say this first age group here, okay? If 357 of them did, if I do the formula that I showed you, 357, okay, and I make it as a fraction, I divide it by the total that they ask, which is 744, okay? I'm going to do some math here, and I'm probably going to get a decimal, and you can punch that into your calculator, but it would be something like this, 0.4798, okay? 0.47, you can check on your calculator, 8. All right, you remember the rule. We want to express probability, experimental probability, and relative frequency. We want to express those as percents. So I'm going to move my decimal point 2 places here and get 47.9%, or I could say approximately 48%, okay, about 48%, okay? And then what about the next group, the 45 through 64-year-olds? Well, if I do my math, I would take, okay, well, 342 of them said, yeah, I drink a cup a day, but they only asked 519 of these people. So if I plug that into my calculator and I go 342 divided by 519, I will get on my calculator, I'll get a decimal, 0.65. It'll actually probably look more like this here, 0.6590, okay? Change that to a percent, which is 65.9, which might be approximately, I want you to look at this little symbol I'm doing, approximately 66%, okay? So, just a couple of things here. You see this little symbol here, these two squiggly lines like that? That means about. Instead of saying equals exactly, when they bend them a little bit, it looks like this, it means approximately, okay? And then the next category, the 65-year-olds plus, if I punch that into my calculator, I could figure out, okay, well, what percent of them do? 196 out of my 266. And I want you to notice something kind of interesting here. That equals 0.7368, which rounds out to about 73.6%, okay? Or you could say 74% if you wanted to round it up, okay? Because of that 0.6. Now, which age group is most likely to drink a cup a day? Well, this last group here, these older people, 74% of them drink a cup. The 45 through 64-year-olds, 66, and then you have 48. The older people are the ones drinking the most coffee per day, okay? And so I have now calculated the relative frequency, but also the experimental probability that someone from each age group will drink a cup per day. I can kind of guess. It's probably likely that in the 18 to 44-year-old age group, about 48% of those people are going to, just a second, let me fix this real quick. Go back to my screen here, drink a cup per day, okay? So that is how we calculate experimental probability and also relative frequency. It's the same formula. Divide how many times it happened by the total that were surveyed, get a decimal, change the decimal to percent, and you have both relative frequency, but also you have experimental probability. I hope this was helpful.